In this video we're going to calculate the volume of this object. So firstly we need to pick a side to calculate the area or number of different sides if we're going to break the object into sections. Calculate the area first, then multiply that area through the depth of the object. The area needs to be the same all the way through the depth. So for example, if we choose this area here on the end, we need to make certain that the area is the same if we were to cut the object anywhere along the depth of that object, which is 10 centimeters. So because we have a big piece missing in the center, we need to chop this into sections. So let's chop it here, then calculate the, we could do this a number of different ways, but one way that I'm going to choose is calculate the area of these top sections, multiply it by the height or the depth that area goes through the object, which is 9 centimeters. Add up those two sides, the left hand side and the right hand side. That will give us the volume of each of those sides. Then we just need to calculate the volume for the center section, so I'm going to call that a different name. So let's give this A1, A2 and A3. So A1 equals 2 centimeters multiplied by the distance from there to there, which is 10, which is equal to 20 centimeters squared. That's the area of that top section there. We know that A1 equals A2, this second one, exactly the same measurements, which equals 20 centimeters squared. And secondly, we're going to calculate A3. So A3 equals the height there and the width from there to there. Now we know the height from there to there is 9. We know from there to there is 7. So the difference between these two will be the height there. So 9 take away 7 is 2. So 2 centimeters multiplied by the distance from there to there. The reason we're going from here to here is because we're going to calculate the volume in these separate sections separately. So from there to there, we know from there to there is 8. And we know there's 2 on either side. So 8 take away 4 is 4. So we know that's 8 centimeters squared. So let's firstly calculate the volume for this side, the left hand side there. We need to take that A1, that area of that top section, multiply it by the depth that area goes through the object, which is 9 centimeters. So we'll call this V1, we'll call this V2, and we'll call this V3. So V1 equals A1, which is 20, multiplied by the depth that area goes through the object, which is 9 centimeters, which is 180 centimeters cubed. So cubed for area, volume, square for area. Volume 2 equals volume 1, exactly the same left hand and right hand sides, which equals 180 centimeters cubed. And volume 3, the center bit, equals the area A3 multiplied by the depth that area goes through the object, which is 10 centimeters. So 8 multiplied by 10 equals 80 centimeters cubed. So now that we've got the volumes of each of the sections in this object, we can just add them together to get the total volume. So total volume equals, or better still, volume total equals V1 plus V2 plus V3, 180 plus 180 plus 80, which equals 360 plus 80, which equals 440 centimeters cubed. That's the total volume of this object. Next, we're going to calculate parameters on this particular shape. We're going to calculate the distance from here to here, and we're also going to calculate the height of the triangle. We're given the volume of this shape here, so we can use our formulas to calculate, go sort of backwards and calculate these measurements. So let's call this H and let's call this D for depth. We're given the side lengths of the triangle, and we know that this is from the center to the top is a right angle triangle with the symbol there. We have, with triangles, right angle triangles, here we have, we know each side from the middle to the end is 5. We know this one is 13 centimeters, but we just don't know H. So one way we can do this is use Pythagoras. Pythagoras has a formula that says c squared equals a squared plus b squared. C is always the hypotenuse, and a and b can be either one of the other two sides, this one or this one. So let's plug the numbers in. We have 13 squared equals h squared, so we'll make a be h in this case, plus 5 squared. H squared equals plus 25. Let's get the numbers to the left hand side. So we have 13 squared take away 25 equals h squared. 13 squared take away 25 is equal to 144 equals h squared. So the square root of 144 equals h. So 12 equals h. So now this is equal to 12. So we know h, and now we need to find d. So that equals 12. Now we know that we have a triangle there. If we calculate we know the formula to calculate the area for a triangle. So area of triangle equals half times the base times the height. We know h, we know the base length of the triangle. So we can calculate the area of this complete triangle on the end here. So half times the base is 10 times the height is 12. Half times 10 is 5, so we have 5 times 12. Which equals 60. And centimeters squared. So the area of this triangle on the end here is 60 centimeters squared. To get the volume, this 4,800 centimeters cubed, they must have multiplied 60 by the depth. So we can say volume equals 60 multiplied by d, which equals the volume of 4,800. So you can see here we have an equation. 4,800, I'll just write that 4,800 on the left hand side, equals 60d. We need to isolate the d to find d. So to do that, we can get this 60 on the left hand side. To get rid of 60, we can divide 3 by 60 on the left hand side and the right hand side. Remember what we do to the left hand side, we also need to do to the right hand side. So 4800 divided by 60 equals 60d divided by 60. The 60s will cancel out. 4800 divided by 60 is equal to 80, which is equal to d, and that's in centimetres. So d is equal to 80 centimetres.